Okay guys, we're going to talk about inverse functions today so that we can get to these two here, which are a pair of inverse functions. Okay, I'm going to go all the way back to something from middle school, the additive identity. The additive identity is the number 0, because any number a plus 0 is equal to a, like 8 plus 0 equals 8. It's you add that number and it doesn't change the value. The multiplicative identity. The multiplicative identity is the number 1, because any a times 1 will be a. Like 4 times 1 is equal to 4. Multiplying by the multiplicative identity 1 does not change the value of the number you started with. Okay, and then most important here, the function identity. The function identity, which you may not have heard of before, is f of x equals x. Think what happens here. Put in a 4, you get a 4. Put in a 6, you get a 6. Put in a -2, you get a -2. Here are numbers that go with the function identity. 2, 2, 0, 0, -5, -5. Whatever you put in for x, you get for y. Okay? So whatever number you put in basically doesn't change the value, just like these two. Or the other way to look at it is, let's see, what was I going for here? F of g of x. If f of x is just equal to x, no matter what g of x is, if I put g of x in there, it's not going to change. It's just going to be g of x. And if I go g of f of x, well, if I take f of x, which is just x, and I replace it for where x was, I'm just going to get g of x anyway. So when I use the composition of functions with the identity function, it doesn't change it. So look, here's an example. F of x is equal to x, the identity function, and then we have this quadratic, a trinomial. I'm going to find f of g of x. Okay, watch what happens. F of g of x, I'm going to put this entire g of x function where x is. I get rid of the x and I replace it with 3x squared minus 7x plus 3. It did not change the value of g of x at all. And then g of f of x, if I switch that around, well, look how this goes. I'm going to take this function and I'm going to put this x wherever I see an x. That's not going to change any of those either. So I get the same thing, the original g of x, whichever direction I go. Okay, a function is 1 to 1. We got a name for a pair of functions, or a function, I guess, is 1 to 1, and this is how we like to write that, by the way. 1 to 1s with a hyphen in between. If its inverse is also a function. Okay, so graph each set of inverses and answer the question, is the original f of x a 1 to 1 function? So here's x squared. I'm going to put a point at 0, 0, and then at 1, 1, at 2, 4, and at 3, 8. That's not right. 3, 9. How dumb am I? Okay, -1, 1, -2, 4, and -3, 9. So there is the original function. Okay, and then plus or minus the square root of x. Well, that would be the point 0, 0, and then 1, 1, and then let's see, 1, 2, 3, 4, 2, and then 9, 3. So there's the top half, that's the positive part, and then the negative half would be at -1, -2, and -3. So there is the inverse. Is the inverse a function? Nope. So here, f is not 1 to 1. That's what we just learned, because its inverse is not a function. Now we're going to graph x to the third. Put in a 0, get a 0. Put in a 1, get a 1. Put in a 2, that's the 8 I was looking for a little bit ago. You get a -1, put in a -2, you get -8, and you have the swooshy. There's our swooshy. Y equals x to the third. Now the cube root of x, put in a 0, you get a 0. Put in a 1, you get a 1. To get a 2, you got to take the cube root of 8, so we go way out here to the point 8, 2. And so the cube root function looks like that. Now if I go -1, I get -1. And to get to -2, I'd have to go -8, -2. If you don't understand what I mean by that, put in a -8 right there. The cube root of -8, the cube root of -8 is -2, because -2 times -2 times -2 is -8. Now look, here's the inverse right here. That's the cube root function. That does pass the vertical line test. And so yes, this is a function. And so I can say f of x equals x to the third is 1 to 1. All right, let's go to the next page.